Hello to Dr. Chung Ping Ping. We are group assignment 21. In this video, we will present about material selection and sustainability. Our group consists of two members, which are Ting Khou and me, Michael ANAK. So the equipment that we have chosen is a hockey stick. A hockey stick, as defined by Oxford English Dictionary, is a long, thin tool with a curved end used to hit or guide the ball. It is the most essential piece of equipment in hockey, as players cannot play without it. Modern hockey sticks have evolved significantly to meet the needs of the game. They are now crafted using a variety of materials to optimize performance and longevity. These materials are carefully selected to achieve the perfect balance between strength, flexibility, and lightweight, improving the player performance. There are 6 key properties which will be discussed in this video. The first key property is lightweight. A lighter hockey stick is important as it makes it easier for the players to handle, pass, and shoot, allowing them to react quickly. The next key property is high shaft stiffness. For power and control, the shaft must be stiff. In order to increase the force behind a shot, a stiffer stick can collect and release the energy more efficiently. This allows the player to pass and shoot more accurately. Then, the next property is high tensile strength. A hockey stick must endure intense play like shots, blocks, and face-offs without breaking or deforming. Another property is high yield strength. This means that the stick can withstand significant stress before permanent deformation occurs. The hockey stick must also have a good corrosion resistance to wear and tear, as it will last longer, making it more reliable over time. Lastly, it is better for the stick to have lower cost. This ensures that the equipment is more affordable to players. So the first candidate that we had choose is European ash wood, which is a natural polymer. Its scientific name is also known as Fraxinus excelsior. For the key properties, it has a low density of 0.64 gram per cubic centimeter, making it lightweight and easy to handle. Its tensile strength is also low at 49.26 megapascal, which may limit its ability to resist breaking under intense force. The material also has a low modulus of elasticity of 12.31 gigapascal, which translates to a lower shaft stiffness and reduced energy transfer. Its yield strength is also low, meaning it deforms easily under high stress. European ash does exhibit a good natural resistance to decay and wear, contributing to its longevity. European ash is also cheap, making it affordable for players who don't have enough budget. While European ash wood has benefits like being lightweight, cheap, and corrosion resistance, its low tensile strength, shaft strength, and yield strength limits its suitability for modern hockey sticks. Players at competitive levels require materials that provide higher strength and performance to withstand the demands of the game. That's it for my part. For the next part, I'm going to pass it to Karen.
Thank you, Michael. The second candidate material for hockey stick will be carbon fiber reinforced epoxy. It is a composite material which has low density, about 1.42 grams per cubic centimeter, so this material is considered lightweight. It also has high tensile strength, about 1040 megapascal, means it can withstand high stress before total failure. Carbon fiber reinforced epoxy also has a high modulus of elasticity, around 101 gigapascal. So it is a stiff material, which means it can resist the change of shape. In addition, this composite material has high yield strength, about 945 megapascal, so it can withstand higher stress before it is plastically deformed. Carbon fiber reinforced epoxy also has a long fatigue life, which means that it can sustain continuous stress under longer periods. It is also an important factor for hockey sticks because stress will be applied continuously to the hockey sticks when the player hits a puck. Also, this composite material has corrosion and wear resistance, so it can be used for a longer time without any damage. Although carbon fiber reinforced epoxy can perform various demanded properties, it is expensive due to the high production cost. Its raw material, which is carbon fiber, requires high cost. Next. Here is the comparison of the two candidates, which is European ash wood and carbon fiber reinforced epoxy. For the first key properties, both candidates have low density, so both of them are light. Next, for high shaft stiffness, carbon fiber reinforced epoxy has a higher modulus of elasticity, which is 101 gigapascal. Next, for high tensile strength, carbon fiber reinforced epoxy has high tensile strength of 965 megapascal, which is much higher than European ash wood. Next, carbon fiber reinforced epoxy also has higher yield strength, which is 945 megapascal. Next, for corrosion resistance, both candidate materials can fulfill these key properties. Last, for the cost, European ash wood is cheaper than carbon fiber reinforced epoxy. In short, carbon fiber reinforced epoxy is chosen to be the material for hockey stick because this composite material can fulfill most key properties needed for a hockey stick. Next, let's discuss the long-term sustainability and socio-economic considerations of the material chosen, which is carbon fiber epoxy matrix. I will further discuss three relevant issues, which are recycling, manufacturing, and carbon dioxide emissions. First, in terms of long-term sustainability use, the material used should be recyclable. For your information, carbon fiber reinforced polymers are difficult to recycle due to their structure. It utilizes cross-linked thermoset polymers for their matrices. Here is one of the common methods of recycling, which is pyrolysis. It is a thermal recycling method that extracts carbon fiber from the carbon fiber reinforced polymer at an elevated temperature around 500 degrees Celsius in the absence of oxygen. It is able to recover carbon fiber with 98% of efficiency with comparable properties with virgin carbon fiber. It also consumes 5 to 10% of the energy of the virgin carbon fiber production. Next, let's discuss the manufacturing process of carbon fiber epoxy matrix. The process is 4.6 times more energy intensive than conventional steel, which means more energy is needed. Focusing on the carbon fiber, which is a part of this composite material, during production of carbon fiber, toxic gases such as hydrogen cyanide and ammonia will be emitted. It is important to mention that nearly 50% of the precursor, which is the raw material of carbon fiber, is lost during the process. Carbon fiber is also considered as high cost. Thus, the production of carbon fiber reinforced polymer requires high cost. That's why it is expensive. Last, let's talk about carbon dioxide emissions. For this section, we will focus on carbon fiber, which is a part of this composite material. Although the production of carbon fiber will generate 15 times more carbon dioxide than conventional steel, it can be used for negative carbon dioxide emissions because it consists of 95 to 98 weight percentage of carbon element. It is estimated to have about 0.7 gigatons of negative carbon dioxide emission and a respective market volume of 200,000 kilotons of carbon fiber produced by 2050, which means each ton of carbon fiber produced can store about 3.5 tons of carbon dioxide. In conclusion, we have discussed the key properties for good hockey sticks. The hockey sticks should be light, have high shaft stiffness, high tensile strength, high yield strength, and low cost as possible. By comparing the two material candidates, which is European ash wood and carbon fiber reinforced epoxy, carbon fiber reinforced epoxy is chosen because it can fulfill most of the key properties stated. In addition, we also discussed the long-term sustainability and socio-economic considerations of carbon fiber reinforced epoxy, which includes these three relevant issues, which is recycling, manufacturing process, and carbon dioxide emissions. And here are our reference. Thank you.